Hey there, everyone. So we need to take a minute to go over something that we're going to need to know to solve some of the exponential function problems that we're going to be working on. Okay, we need to know how to divide with exponents. All right, let's just jump into it so you see what I mean here. You may have learned this in maybe pre-algebra, but well, there's a good chance you're pretty rusty with it, which is to be expected. So let's just jump into it, okay? So what if we're dividing two of the same base, right? What if we're dividing two of the same base raised to different powers, all right? Like what if we're dealing with x to the third power divided by x to the second power, okay? Well, let's think. What does x to the third power mean? All right, it just means that the base is being multiplied by itself 3 times, right? And on the denominator, what does x to the second power mean? Well, that just means x is being multiplied by itself twice, right? Okay, well, we should know by the properties of fractions that we can cancel out the same factor if it appears in the numerator and the denominator of a fraction, right? We should know that we can cancel out these factors of x, right? And we'll be left with what? We'll just be left with x in the numerator, right? Which equals x to the first power, right? Remember, if we just have a base by itself, that means that base is raised to the first power, right? And what does x to the first power also mean? Well, that means x to the third minus 2 factor, right? You see that what's the word? You see that pattern? Well, let's see if it holds up, okay? Now that we know how to do that, let's just do one more example and see if that pattern that we've just noticed holds up. All right, let me make some room. All right, make some room over here. There we go. Whoops, that's not what I want. There we go. Okay, what if we had something like, let's use y this time. What if we had y to the 7th power divided by a y to the 4th power, okay? Just like we saw before, we've got two bases, well, two of the same base, an numerator and a denominator with different exponents, right? Okay, let's see what we can do here. Well, y to the 7th power means y times itself how many times? 7 times, right? So let me just write all that out. This is what y to the 7th power means, y being multiplied by itself 7 times, right? And what does y to the 4th power mean in the denominator? Well, of course, it means y multiplied by itself 4 times, right? Okay, so what can we do with this? Well, we can cancel out one pair of y, another pair, right? Another pair, and another pair, right? Okay, now it's been totally simplified, and what's left? There's 3 factors of y left in the numerator at this point, right? Which means what? Which means y to the 3rd power, okay? So y to the 7th power divided by y to the 4th power is equal to y to the 3rd power, right? Well, let's take note of something. Doesn't 7 minus 4 equal 3? It does. So doesn't y to the 7th power divided by y to the 4th power equals y to the 7 minus 4th power? Do you see that? Because what is 7 minus 4? It's 3, right? Yes. And this is a general phenomenon. So let me write down the punchline here, okay? Let me write down the punchline here, because this is something that we're going to make extensive use of as we go ahead and work through exponential functions, okay? Let's keep x. Let's say x raised to any power n, okay? Divided by x raised to any power m, all right? This does always equal x raised to the n minus m power, okay? So I know that's a lot of variables to deal with, but let's just take a minute and see what it means, right? So if we had something like y to the 13th power divided by y to the 5th power, right? We automatically know that this means y to the 13 minus 5th power which is y to the 8th power. Okay? If we had something like x to the 21st power divided by x to the 10th power, right? We automatically know this means x to the 21 minus 10 power, which is x to the 11th power, right? So let's look at a couple more examples. Let's keep my main point up there to the left, okay? And let's just look at a couple more examples to sort of drive the point home, okay? Well, let's use some real numbers, right? Let's use some real numbers. What if we had something like 3 to the, let's say, 8th power, okay, divided by 3 to the 5th power, okay? Well, our statement here tells us that this should equal 3 to the 8th minus 5 power, which is equal to 3 to the 3rd power, right? Okay, so what is 3 to the 3rd power? 3 to the 3rd power is 27, okay? It is 27. So let's see if we can reason through this and sort of verify this, right? Let's try to verify that our statement over here works with some real numbers, right? Okay, so let's write out, let me make some room out here, okay? And let's write out 3 to the 8th power. That's 3 times itself 8 times, right? All right, this is a lot of 3's to write, but that's just what 3 to the 8th power means, right? It means 3 times itself 1, 2, 3, 4, 5, 6, 7, 8 times, right? And what does 3 to the 5th power mean in the denominator? That means 3 times itself 5 times, right? Okay, so now we have our fraction written out. Okay, we can cancel out one factor of 3 here, can cancel out another factor of 3, and another, and another, and finally another, right? And what's left? What's left are 3 factors of 3 in the numerator. So this is equal to 3 times 3 times 3. And what is 3 times 3 times 3? It is indeed 27. Let me write a better 27 than that. Goodness gracious, it is 27, just like our formula predicts, right? So we can be 100% confident that this here is true 100% of the time, all right? X to the nth power divided by x to the nth power is always equal to x to the n minus nth power. And just to give one more concrete example before we head out, just to drive it home one more time. All right, let me get rid of this right here. And let's give one more example, something like, I don't know, r to the 17 power divided by, I don't know, r to the 6th power, right? Well, we can calculate this automatically. Like always, this is just going to be r to the 17 minus 6th power, which is r to the 11th power, right? And this always works.